Hi, I am Ishan, working with Jennifer Trueblood at Vanderbilt University. This is a pre-recorded presentation for the 2020 meeting of Society for Mathematical Psychology. Today I'm going to present a grammar that can be used to write down strategies in multi-attribute choice. In this paradigm, participants have to make a choice between two options on the basis of various cues. In our experiment, we wanted to see how participants learned how to do this task in an unknown environment. They were provided with true or false binary cues to make this decision. There was an explicit cost for searching for information. They could change the search order at the end of every trial. They were thereby expected to form a strategy during the 60 trials in which they received feedback. Even in this rather simple task, there are 120 different orders and 363 different states per order. So the question is, how do participants traverse the space and go about formulating strategies and solving the problem? Firstly, we notice a lot of individual difference in the strategy adopted. We show four examples here. The first one on the top left is a classic take the best. That is to keep looking for cues until the first discriminating cue is found. Here the participant looks at cue F2, and if that does not discriminate, they look at F4. The second one on the top right is a weighted additive model like strategy, where the participant looks at all the cues and then weights them by their importance and uses this to make their decision. These are the two most talked about strategies in the literature. However, we also notice hybrid strategies such as the one on the bottom left, where they look at F2 and saw all the other cues based on whether it discriminated. In the one on the bottom right, the participant waited for two cues to discriminate in the same direction and then used them to make their decision. To gainfully talk about these strategies, we need a formal language to describe them. The grammar that we propose is an attempt at that. It is composed of elementary operations and actions that could be used to write down a strategy. The list mentioned on the slide governs the syntax of writing meaningful strategies. The first five rules are directly from the problem description. For example, the first one states that in the beginning, one needs to decide on the order and then make a decision. The third and fourth mention the decisions available to the participant. The sixth rule gives a syntax for conditional decisions. The seventh speaks about more complex conditions that can be written down. The eighth rule forms a bridge between conditionals and numerical comparisons. The ninth one talks about how these numeric operations can be expanded upon. The 10th and 11th rules connect conditionals and numbers to outcomes and properties of the cues. We show this for take the best and weighted additive model in the blocks below. The other strategies mentioned in the previous slide can also be expressed in this framework. One of the advantages of this is that it integrates the search order and decision rules into one framework. It has been realized that information search rules and are connected to decision rules and that it is beneficial to study them together. Further, it changes the perspective from the toolbox metaphor, which talks about predefined heuristics, to a framework in which these strategies can be constructed. Other perspectives in research assert that these strategies are endpoints on the spectrum of compensatory and non-compensatory strategies, or simple or cognitively demanding strategies. This fills the gap in between. This might also explain why participants adopt a suboptimal strategy. That is, it may be an easy to articulate strategy, or this strategy might be some sort of a local minimum. Finally, it clarifies on what the internal structure of these strategies are. However, there are several questions for future work, like what the justification is for these elementary operations. Is there a reason for basic mathematical operations to also be elementary cognitive operations? Further, as seen on the previous slide, the string length for WADD strategy was quite long. But due to the repetition in the string, it is easy to say that it is not a very complex strategy. But how exactly do we define complexity? Further, can we add other things to our grammar, such as sets or loops, to make this simpler? That is, can we use sets or loops to define complexity? Another question is, how exactly do participants explore the space of strategy and make their inferences? Finally, can we use such a framework to create higher order concepts that is useful in decision making, such as evidence accumulation? So, hopefully you think this is a useful approach. I would love to have feedback and suggestions on how we might connect this to existing literature and how we might formulate testable hypotheses that we can experimentally verify.